Now, from reading your book, you may know that the derivative of the natural logarithm function, this is the first one that we cover, the derivative of the natural logarithm function, ln x, is equal to 1 over x, provided that x is greater than 0. This fits with our restriction on the domain of the natural logarithm, right? So if you're looking at this restriction right here, you should be thinking, oh yeah, domain of all values of x is from 0 to infinity for a natural logarithm function. So that should fit the situation. Okay. Now, if we were to treat this chain rule style, we would say, well, the derivative with respect to x of the natural log of u, where u is a differentiable function of x, would be equal to 1 over u times the derivative of u over du dx, or in other words, we call it u prime over u. So we might ask ourselves the question here, I guess, before we even start this. How did we get here in the first place? Where did this derivative come from? And what we're going to do is we're going to go back, and I'm just going to illustrate why this must be by rewriting this expression over here on the right-hand side of your screen. Y equals the natural log of x. How do we get there? Well, let's use our definition. We would say that y is equal to the natural log of x if and only if the base e raised to the power of y is equal to x. And you can take the derivative of this implicitly. If you recall implicit differentiation, that means we take the derivative with respect to x on both sides equally. So we're going to be taking the derivative with respect to x of e to the y and setting that equal to the derivative with respect to x of 1. Of x, pardon me, I'm getting ahead of myself. We know what its derivative is over here on the right hand side. We're going to get 1. But on the left hand side, what happens? Well, the derivative of e to the x was just itself. So by implicit differentiation, the derivative of e to the y is itself, e to the y, times the derivative of y with respect to x. Okay. Well, so far so good, but how do we get this dy dx equals 1 over x? So let's take it one more step. Isolating dy dx gives us the quantity 1 over e to the y. Well, what's y? Remember that y was defined as the natural log of x. And if you are remembering your properties of logarithms and exponents, right, we had an inverse property which said anytime we take e, raise it to the natural log of x power, the result will simply be x. So you guessed it, what's going to happen right here is that dy dx is just equal to 1 over x, which verifies our formula over here for the derivative of the natural log of x. All right, so what about this rule down here? What does it say? Well, we've got f of x is equal to the natural log of x squared plus 4. So by this rule, very easily, what we're going to say is that the derivative of f of x is going to be equal to, let's see, u is taking the place of x squared plus 4. So we're going to take 1 over u to be 1 over x squared plus 4. And we would be multiplying that by the derivative with respect to x of the argument x squared plus 4. And we know what this derivative is going to be. That's 2x right here. So rewriting this one more time, we're going to find that the derivative of f is equal to 2x, which is the derivative of x squared plus 4, divided by x squared plus 4. So this is a really easy derivative to work with. Natural log of u, great rule, and it's going to save us so much time. You'll see in our next examples.